Hi everyone, welcome back to our Science 8 class, and our focus is about physics. I know that you have listened to me and you have participated in our demonstration earlier. So our lesson was about second law of motion. So for this session, we will have our review, and after that, you'll be taking a short assessment through the use of our quiz is application. So now I'm expecting everyone is has their phone, has his or her phone to access our quiz is game for today. So to continue, let us have our overview again. Our lesson is all about second law of motion. But let me give you the overview and objective for today's discussion. One, you're going to define force on your own. Second, describe second law of motion. Third, you're going to explain the relationships among force, acceleration, and mass. And of course, you're going to analyze real life situations by applying the second law of motion principles to predict outcomes. So, to start with, anyone who could remember our discussion earlier. Again, Teacher Irene demonstrated you on how acceleration could be affected by mass or force or the other way around. So, anyone? Let us define first basic terminologies such as force, acceleration, or let me give you a question. What is force on your own words? Anyone? Yes, Justin. Force is, uh huh, force is a push or pull on an object. Wow, that's a great idea, Justin. But let me give you a full definition of it. Force is a push or pull in a particular direction. So Justin really got it right. So let's clap our hands for Justin, everyone. You can use also the button here in our um, discussion. If you are online, please push the clap button so we could also show our appreciation for Justin. So again, it results from an object's interaction with another object. Now, when we say force, when we talk about force, it's about pulling or pushing. So, pulling is the force you exert to move something closer to you, while pushing, again, it is moving an object away from you. So, when you push or pull an object, you are exerting. What is it again, Anna? Yes, it's you're exerting force. So, remember force is included in the second law of motion. But what is the unit for force? Anyone who could still remember? Yes, princess. It's Newton. Very good. Aside from that, we also have kilogram, meter per second squared. Yes, that's right. Now, what can force do? We know that when we push, pull an object, what can it do? Anyone who has an idea? What if you do a hockey game? So a force can move the object. Oh, how? Just like an ice hockey player uses a force to move the hockey puck. So that is how the object can be affected by a force. Another example is when you play volleyball. Who is playing volleyball here? Wow, Dana, it's so nice to know that you're playing volleyball. Hopefully, next time we could also play volleyball. Teacher Aaron knows how to play too. Anyway, how can force affect an object just like the volleyball? As you can see, the kid here, yes, Lori, that's right. A force can not only let an object move, but also it can change the direction. Okay? Aside from that one, force can make a moving object to speed up. Mhm. Not only speed up, but it can also make a moving object stop, just like a baseball player catching the ball. Now, to summarize it all, class, second law of motion can be a representation about how mass, how force, and acceleration could be related. So, let us analyze this. What will happen to the speed, or let's say acceleration, of the bike if you try to remove your 7 kilogram bag as you come back home? So, for example, you're riding a bike going to school, but when you come back home, you left your 7 kilogram bag. Considering you apply the same amount of force when you do bicycling. Anyone who has an idea? What will happen to the speed if you remove 7 kilogram? Yes. Now, in this case here, we are now checking on how mass could affect acceleration, stating that or considering that force exerted is the same. So, when you remove, okay, a mass, it means to say it is making your load or weight lighter. The lower the mass is, the what will happen to the acceleration? Will you speed up or will you slow down? You will speed up. Yes, that's right. Because the relationship between mass and acceleration, anyone can state it? Yes, Dana. Very well said. The relationship between the mass and then acceleration is indirectly proportion. That means to say, the higher the mass is, the lower the acceleration. The lower the mass is, or the lighter an object is, the higher the acceleration. So, did you get something from that? All right. Now, do you have questions? To summarize it all, what are the relationships among force, acceleration, and mass? When a force is applied on a body, acceleration produces in its direction. So the acceleration is directly proportional to force. The higher the force is, the higher the acceleration. And of course, it is proportional, inversely proportional to the mass. Okay, the heavier the object is, the lower the acceleration. And then the lighter the object is, the higher the acceleration. So I hope you understand our lesson for today based on our demonstration and also our short review for today. So, to check your understanding, kindly get your device, cell phone, and open your quizzes account. You can check on the link I'll send you in our line or in our Google Class, or maybe you can use the code on your screen. All right, let's try to see. Okay. Well, thank you so much, everyone, for participating in our class discussion. I hope you've learned something today about the second law of motion, which is the law of acceleration. Thank you so much, everyone, and have a great day. Bye.